Okay, today I have a very special guest. I'm actually excited. Kind of following up from our last podcast where we had Perth-ian. I'm not sure, is that what you call people from Perth, Australia?
Something like that.
Yeah, Perth-ian. And we're following up with a second. His name is Andrew Fitch, and most people know him as the proprietor and main brain behind Nonlinear Circuits. So with that, let's just say hello to Andrew. Hey, Andrew, how's it going?
Oh, I'm good. Yeah, had a good night's sleep, which is rare.
Yeah, there you go. So why don't we start off by having you, for people who aren't familiar with Nonlinear Circuits, why don't you tell us a little bit about what you do and the kind of work that you're doing.
Yeah, I design Eurorack synthesizer modules. I'm pretty much a one-man show, a one-person show. I do all the designing myself and tend to come up with ideas in the shower or other places when I'm not really thinking much and things bubble up. I do all my own assembly here, and I get my circuit boards manufactured in China, like most companies, I guess. But I have a pick-and-place robot here, so I do my own assembly here. But I really love the DIY ethic, so I also sell circuit boards and panels for people to build their own modules, because that's where my background comes from, I guess. I say I'm mostly a one-person show, although I have a good friend called Nathan who he's just supported me from day one and, sort of pushes me and I suppose drives me along. So he's in the background all the time, but although he doesn't actually design modules himself. But he comes up with ideas and comments and, gives me a lot of feedback, positive and negative, as I need it.
Sure.
So, yeah.
Yeah, it's kind of interesting hearing that, because one of the things that I've noticed from the many podcasts I've already done is that in most cases, even people who are like solo anything, whether it's solo artists or solo developers or whatever, there's actually always some sort of collaboration in play. If nothing else, it gives you somebody to bounce ideas off so you can kind of make sure that you're not like completely missing the mark, right?
That's right, yeah. Yeah, Nathan's got a good... You probably heard about Nathan. He worked on the cellF project, which...
yes.
Yeah, he was the designer for that.
Interesting.
But yeah, we've worked together now for, I don't even know how many years, 7 or 8 years, something like that.
Oh, that's cool. You've been on my radar for a while. If nothing else, your blog, which is nonlinearcircuits.blogspot.com, has always been has been one of those places where I could go and sort of like stimulate some of my DIY excitement. I mean, it's interesting because through that site, you really do... I mean, the way Nonlinear Circuits comes across to me is that it actually preferences the DIY world. I mean, you provide opportunities for people to get panels and boards and stuff, but you really push the idea of, hey, make this stuff yourself, right?
Exactly, yeah. It goes back a long way, and you can trace this sort of ethic, I suppose, way back to Serge Sharapnan and the Serge modular synthesizers. Back in the 70s, they set up in an abandoned house at UCLA and charged people, I think it was $400 or $500 to come and build their own synthesizer based on Serge's designs, because that was all the idea, that synths were too expensive. So, let's get synths out to the people. And it was called the People's Synthesizer. And that was always inspiring. And then when I first got into DIY, the first person I got in contact with was Ken Stone of Catgirl Synths.
Right.
Ken's very much was following on with that idea with his designs, and he always shared the schematics and helped people build. And it was just trying to make it so it was cheap and easy to build your own synthesizer. You didn't have to fork out tons of money to get one. I feel I really just carried on with that. It even flowed into, we started running workshops here in Perth about 4 years ago now. I think we're up to workshop number 42.
Oh my!
We do them every month, and every month is a new module. So there's a few hundred people around Perth now that have built their own synths, and it's really quite nice how it's worked out.
Well, it's interesting because ever since I kind of first reached out to Guy Ben-Ary, for listeners, he would have been our last interview. I've been intrigued because I've been talking to different people I know, either from Australia or who know the area, and learning more about Perth, which is really quite a peculiar place in that it is so freaking remote that you all kind of end up having to depend on each other because that's about all you have is each other, right?
Yeah, it's better now we've got internet and cheaper travel, but yeah, back growing up here in the 80s and 90s, it was cheaper for us to fly up to Asia than it was to fly to Melbourne or Sydney on the other side of the country.
Unreal. That's interesting.
And even just to drive across took, 2 days if you didn't stop, and 3 days if you were a normal person or straight.
Unbelievable.
And there wasn't much in between. So, yeah, I think that remoteness sort of pushes us to, into maybe extremes or...
Well, extremes are at least certainly a sense of community, but also it does kind of allow you to kind of focus on your own thing instead of necessarily blending in with what other people are doing, right? And even, despite the internet, I certainly felt this about Guy and some of his projects, particularly this cellF thing. But also, as I kind of was looking at your projects as well, it's sort of like making a decision about this is what I want to do, this is what I want to pursue, and kind of having the ability to say, and I'm not going to necessarily let myself waver because I'm not going to be influenced by a ton necessarily of outside people. I think it's interesting when I look at some of your projects. So recently you made a post about a project, a 555 based resonator, and it's just like on one hand, I think a lot of people would say, well, the 555 has been kind of it's been explored to the teeth. We don't need to spend any more time on that, right? But you have just you're like, hey, no, this is my thing. This is the way I'm going to take it. And you've come up with some really unique ways to approach using that particular circuit to make something kind of unique and maybe a little weird, but certainly your own.
Yeah. I have to be honest with the 555. It is actually based on a very old design.
Oh no! I went down that whole trail, and now I'm not. Whoops! All right, I take that all back. Then.
Yeah, I'd love to take full credit for that, but no, it does actually. It was one that came out in the series called Electronotes. I don't know if you know of them.
Oh, but, yeah, believe me, I have a big stack of them in the corner, being ignored very well.
My version's sort of not straight out of there, of course, but the basic idea was in Electronotes, so I'm sorry I can't.
All right, well, so I take it all back. You've been influenced by everybody, and there you go.
Yeah, I think probably where I guess forged my own little path was through chaos, and that came from. Actually, we've probably got to go back to the beginning a bit. I got into DIY synth when I was living in Japan in about 1998. And it all came from I was buying broken old Korgs and stuff at junk shops and then trying to figure out how to fix them, which is, I suppose, probably how my mind's always worked. And eventually I discovered synth DIY and just started building Ken Stone stuff. And I met a wonderful DIY group in Japan with some really wonderful guys there that taught me lots. You might know of Hoshu. He has a site called Unusual Synth Circuits. Another fellow was Motohiko Takeda. And they're just great people. They're really good. And but after 7 years of that in Japan, I thought, well, I've got to take this a bit further. So I came home and started studying electronic engineering at university. And that was good, but you actually don't learn much electronics when you study EE these days. It's all about management and not getting sued.
Well, that and also one of the things when I've talked to people who are currently doing EE work, it's like, and when you do talk about circuits, it's about the circuits for cell phones because that's where all the money is, right?
Yep.
Interesting.
And most people I studied with went through that whole 4-year degree without even looking at an op-amp or knowing what a resistor looked like, sort of thing. So, but I got to the end of it, and one of my professors was Professor Herbert Yu. He was into chaos, and I'd heard about chaos circuits, and Ian Fritz at the time was starting to. I think he'd released his first chaos design. Mm-hmm. Prior to him, another guy called Dan Slater had published a paper on using Buchla circuits to make chaos. But I got talking with Herbert, and he was just so excited that I even knew what chaos was. He immediately sort of signed me up to write a paper together, and he sent me off to China for a conference, and then he managed to wangle me a scholarship to do a PhD. So I spent the next 4 years after that doing my thesis on chaos or memristor-based chaotic circuits. So I just focused on chaos for 4 years, and especially developing chaotic circuits. And I think that's probably an area I've traveled on my own way to some extent.
That's interesting. Although one of the things I'd say is that chaos is that siren song that seems to have drawn a lot of people into some really interesting circuits. I know just from people that I'd interview, whether it's like Dan Snazel from Snazzy Effects, or just different people have been really drawn in. It's almost like chaos behavior as opposed to either random or completely understood behavior. This chaotic behavior is one of those things that for a certain kind of brain, it like trips the trigger that says, I have to get into this, right? And it seems like that's what happened to you.
I did, yeah. I got fully bitten. You should have seen my professor. He was salivating with excitement when he discovered I knew about chaos.
All right. So what is?
Yeah, he really loves chaos.
Yeah. So what with him? What was the exploration? What did the exploration look like there?
We made a really good team. He basically just was like the. Like the huntsman and sent us off in directions. But I worked with another fellow called Dong, and Dong was an excellent programmer and coder. So I'd work on the circuits. So we would develop circuits both in code, on MATLAB or whatever, and actually build the actual circuits. And when you can get results that way, it's quite a good confirmation that way. I don't know if you know how academia works, but it's publish or perish. So
right,
we were able to publish quite a lot of papers in a short period. Probably I could have finished my PhD in a year or a year and a half, but I was happily sitting back with that scholarship.
Sure, right. So what were the papers that you were publishing? What were they? I mean, obviously about chaos, but focused towards what?
All of ours were on memristor-based circuits or mem-capacitor-based circuits. And that's another quite curious field. Memristors were developed in theory by Leon Chua back in the early 70s. And then I think it was in 2006, Hewlett-Packard announced that they'd developed an actual memristor. And the whole academic world and I guess engineering world got pretty excited about these things because memristors could potentially revolutionize computing in the sense that you can use them for they remember their states, I suppose, but it's not just on or off, but it's anywhere in between. So suddenly you have these basically massive analog computers, and they work on a nanoscale, and you can build them into I guess multi-layered structures instead of single-layered structures, and also they don't use energy when they're remembering things. So there's all these great advantages to them, but it was all in theory. probably the big thing about it you might notice is that no one's actually really come out with a proper memristor product in the last 10 years. I mean, I know one company's put out a chip with 4 memristors on it, and it's $200 for one chip. But the whole thing was that suddenly everyone started writing papers based on the data that Hewlett-Packard published.
Okay.
Which we did too. But because we didn't have a real memristor to play with, we first had to develop circuits to simulate memristors, which we did.
Okay.
So we published papers on that, and then we used these circuits to make chaos circuits, memristor-based chaos circuits and hyper-chaos circuits. And then when you start digging in deeper, the next stage was mem capacitors. So we started developing mem capacitor simulators, mem capacitor-based chaotic circuits. And then we went to mem ductors. I think we only did one on there, and I'd sort of had enough by that point. So I was starting to realize that this was all based on some data that was a bit it was kind of iffy, to be honest.
Right.
Because they've never actually come out with anything solid to say, here it is, here's our working prototype or anything. So I think the way memristors have gone, it's changed direction a bit since those Hewlett-Packard days. It does make my PhD thesis completely obsolete, like a dead-end street.
Yeah, the flip side of it is 200 years from now, people might end up saying, oh, that Andrew guy, he really broke through on a lot of stuff. But who knows, right? We'll all be dust then. But
anyway, anyone can hunt it down if you want to search at the University of West Australia.
It sounds really, really fun. So how did you go from bizarro and sort of like very theoretical paper writing for your PhD to designing circuit boards for musicians?
I mean, I was already into synths and already into designing circuits, and it's one of those things that's a complete obsession. So any circuit I looked at, any paper I'm reading, I'm thinking, can I make a module out of this?
Right.
And I've got literally boxes of I don't know, I call them my boxes of dumb ideas, but there's lots of ones that didn't work, but for every, I don't know, maybe every 10 or every 20 you try, you find one that's kind of interesting. Or, of course, you have to massage it somewhat to make it suitable for use as a synth module, but that's all just part of the process. And there's quite a backlog of things that need massaging, I suppose.
I suppose, but now the flip side of it is, though, you have kind of developed a business model, which is, maybe no circuit is too bizarre to at least give a try, right? I mean, if you're doing, you talk about doing, like, you're on workshop number 42 and you're doing, like, a new circuit a month. I mean, you're going to run out of, like, here's a fat-sounding filter. You're going to run out of those pretty quickly, right? And at some point, you have to be like, well, here's the module that simulates a spinning top or something like that.
Oh, that's a good idea.
Yeah, there you go. That one gets my name on it.
Well, that was something with the workshops. That was a real driving force, and it's why I think I actually posted up a new module for sale last night. I noticed it's number 77 on the list. That's the workshops really push me to come up with a new module every month, and maybe to some extent it's quantity over quality, but I try and make sure everything works, and it's not too much of a disaster. But the workshops are a good way of testing new modules as well. So we usually build it at the workshop before I release it on general sale.
Sure.
Because at the workshop I see 30 to 40 of them get built, and I test them, and I can see where people have problems, or I could see where I might have been able to improve the design.
So you get 30 to 40 people coming to these workshops?
Yeah, it's really full on.
How big is Perth?
I think it's just top 2 million people now.
Interesting, because I'll tell you, in a city that size, in most places, trying to get 10 people together seems to be an awful lot of work. So again, it seems like there's kind of this unique thing in the air there that causes this community to to exist. It's really kind of cool.
Yeah, and it's not, of course, it's not the same 30 to 40 people every month. There's,
Right.
it's like our workshop last week, I think there was maybe 10 new people that hadn't come before.
Interesting.
So, and always the idea of the workshops is it's not just buy my stuff, but it's just to help people get their skills up and get the confidence to build modules, and then they can just stay home and order in kits or boards or even work on their own designs, and that's what a lot of people have ended up doing. So there's probably 2 or 3 people that have come from day one, but otherwise it's kind of a general rotation of new people coming in and other people dropping off as they've got their confidence and skills up and then move on. So,
Sure.
Which is how I've always wanted it to work. So it's been really good.
So when people, I'm kind of curious about this idea of workshops, building workshops, and especially ones that are kind of ongoing. So you're saying that like there's maybe 10 new people each time. I mean, are you having to sort of like each month kind of have a special corner where it's like, okay, we're going to learn how to do solder. Here's how much solder you put on the joint, Is it like every month having to kind of go through that process with people?
Luckily Nathan does that.
Nathan saves the day. All right.
Nathan's a really good friend. He's got it down pat.
That's cool.
He's got his spiel for getting people to start soldering to build their first module, which is always a power supply. So yeah, he's got that pretty smooth. We have another fellow that comes to the workshops called Steve, who always helps out every month as well. Yeah, whereas I'm usually pretty busy at the workshops just testing modules.
Oh, okay.
So we arrive at 4 in the afternoon and sort of an hour or two to set up and quick dinner, and then from 6 p.m. it doesn't stop until about 1 in the morning.
Oh, interesting. Is this like a maker space kind of a place that you work out of, or where do you do these?
It's a hackerspace called Artifactory.
Oh, okay.
And they're in a warehouse in an industrial zone. They've got laser cutters, they've got lots of benches and soldering irons and good lighting, and they love having us because we're right in with what they're about.
With the aesthetic of it, yeah.
Yeah, and they also run a monthly, which Nathan and I are also involved in this, a monthly noise show called Noise Machine. And that's been running now for, I think it's 7 years or something. And every month it's 8 people get up and do whatever they like for 10 minutes each. So it's, you can be as loud or obnoxious as you want, but it's only 10 minutes, so everyone enjoys it.
Yeah, well, that's the thing. I mean, if it's 10 minutes each, that means really you can swig a beer and then it's time for the next person. So no matter how bad it is, it's only going to last you one beer, right?
Yeah. But there's been some fantastic shows on. There's some less than fantastic and some completely weird. And
it's really cool. Yeah. Now, one of the things I notice is that you do fully fleshed out PCBs and panels and stuff for all of your circuits. Is that when you do these workshops? Are you bringing in these boards and stuff? Are you manufacturing stuff in turnaround that quickly?
For the workshops, we bring in circuit boards and panels, and we make, again with Nathan, he comes over one day a week before the workshop or so, and we make all the component kits.
Okay.
And then at the workshop, these days it's all surface mount, and I take my reflow oven into the workshop.
Oh, interesting.
And so we stencil on the solder paste, and people just drop the parts on the boards, and then they cook them. And then once it's cooked and cooled down, they put on the pots and the jacks, the LEDs, and bolt it together. And doing it this way, we have a pretty good success rate. Don't know if I'd want to put a number on it, but sort of 4 out of 5 work straight away, and maybe 1 in 5 just needs a minor tweak to get it working. But generally, everyone goes home with a working module at the end of the night.
Well, I think that's pretty remarkable, though, because one of the things I would say most people are scared shitless by the idea of dealing with SMT, and it's like you're not only helping people do it, but making it sound like it's pretty easy to pull off. That's really great.
It's one of those things that until you try it, you don't realize
Yeah.
how easy it is. And even myself, I was reluctant for a long time. I don't know, I was pretty much stuck in the 70s, I think. It has to be all analog and through hole.
Right.
I'm not that old, but it's just, I think you're nostalgic for that childhood time. So for me, it's the 70s. But once I started using SMD, I realized it's way quicker to work with, even soldering by hand. When you're using it with an oven, it's almost foolproof. Everything just works. So,
Right.
Yeah.
Now, the front panels that you do, are those is that circuit board printed as well?
Yes.
Oh, okay.
Yeah. The panels are, they're done as 2 mil thick circuit boards.
Oh, okay.
And I do a little fiddling of the Gerber files so that the actual lettering is the copper traces rather than ink.
Oh, nice.
And then that's finished with what they call a NIG gold, so it's gold-plated copper for the lettering.
That's got to light up pretty nicely, yeah.
Yeah, it's quite durable. There's good and bad things about using circuit boards as panels. They're actually quite strong. They're difficult to break, but probably depending on manufacturer, you get a large amount of them arriving scratched or scuffed. Because they're a bit rough at the factory because they don't care about them being panels. To them, it's just circuit boards. So
sure.
I've found good manufacturers now, and I probably have about a 10% reject rate, which is pretty much what any manufacturer has, whether from wherever they get their panels made. But in the early days, yeah.
Do you see much variation, like either in the panel color or like the thicknesses or any of that, or are they pretty uniform?
The thickness, you always set the thickness at what you want it to be, so that's the same. I always choose 2 mil.
Okay.
But yeah, I normally just get the white panels, but I've seen at least 4 different shades of white. Yeah, so, but it's not, I don't fuss about these things too much, to be honest. It's, it's how does it sound in the end? It's the main point.
Right.
Yeah.
Now, a long time ago, I used to work with Grant Richter on stuff, and we actually toyed around with the idea of using circuit board material because, especially back then, trying to get a metal place to do panels was just obnoxiously hard. They just didn't want to deal with the small quantities and anything that had any kind of unique look to it, right? They didn't want to hear about it. But at the time, there was a lot of concerns about, do you have to worry about them shattering, or is it going to flex too much, or whatever? Now, one of the things I notice about a lot of your panels is they're relatively full. So I imagine, like, between the jacks and the pots, that keeps everything pretty bolted in and pretty well solid just from all of the connections to the circuit board, right?
Yeah. There's once it's all put together and in your case, there's pretty much no flex at all. I think you'd have a hard time making it flex, I think.
Yeah.
I'm testing right now, actually.
You're pressing on it with your finger.
I can't see any bending.
That's interesting. I think it's really cool, and they really look sharp. That white coloring is pretty slick. Now, I also see that in addition to the PCBs and the panels, you also do sell assembled modules. Now, in your experience, what is the percentage of people that are wanting to DIY versus the percentage of people that just want a module, just build it for me and send it?
Maybe 2 to 1. I haven't thought about that before.
2 to 1 DIY?
Yeah, mostly DIY for me. I guess, obviously, I'd probably attract DIY more than people that want assembled. And also, I don't really, I don't really advertise or push the assembled stuff that well. I think people have to look for it. I'm not sure why. I just have this, I don't know. I'm not sure why I don't do that, but it's maybe because it's a lot of work.
Right. But the DIY ones are full on surface mount, right?
Yep.
It's interesting. I have to admit that, maybe it's just my age, right? But I can really imagine I've got a box full of all the resistors and capacitors and everything I need for a through-hole kit job. I wouldn't even hardly know how to start with SMT.
Right. Okay.
Well, no, I mean it's just like
Yeah.
help me understand what is you went through the transition moving from through hole
Mm.
to surface mount. This, I mean, how do you even buy resistors, right? I mean, there's these little things that look like bugs. I mean, I sound like old man of the sea here, so pardon me, right? But how do you like buy
Yeah.
a reel of them? Do you buy like how do you even get the parts? I don't even really get it.
Okay. I mean, I'm a bit more probably extreme than most, but I buy all my resistors on reels. Usually it's about 4,000 to a reel,
Hmm.
and the average cost is about $10 for a reel.
Okay.
But otherwise, there's a good online store is called Tayda Electronics, Tayda, and they're very cheap, and you can buy resistors, surface mount resistors in blocks of I think 50 or 100. It's about $1 for 100, so 1 cent each.
Oh, okay.
And the only sort of special tool you really want is some nice tweezers. And if your eyes are getting on a bit, maybe some like a watchmaker's visor, that sort of thing, which I
Uh-huh.
use. I have one pretty much permanently attached to my head these days. Yeah, that or some sort of magnifying lamp. Not everyone needs one, but I certainly do.
Uh-huh.
And soldering iron, yeah, fine point is nice to have, but it's actually not that critical. I think more just to be able to work quickly is more important. I always have 2 irons on my desk, and one is a fine point, the other's quite blunt, but I tend to use the blunt one because it heats things up much more quickly, and
Okay.
so I can work faster. So when you're soldering on surface mount parts, you just go through the board and put a blob of solder on one side. Like each surface mount resistor will have 2 pads.
Mm-hmm.
So you put a bit of solder on one pad, grab your resistor with the tweezers and put it in position so it's sort of sitting up on top of the lump of solder, and reheat the solder so the resistor plops down onto the pad, and then just let it cool down and solder up the other side. And that's pretty much it. There's no trimming of leads or anything, or it's
Right.
very, very fast. Yeah.
Interesting. Yeah, it's funny because I have to admit that surface mount is one of those things. There's an intimidation factor to it that's made it really hard for me to consider going there.
And I actually converted slowly from through hole. So you can sort of see through my modules, the early stuff's all through hole.
Mm-hmm.
And then you start to see there's a few 100K surface mount resistors on there. And they're what's called 1206 size, which is sort of the biggest surface mount size.
Okay.
And then there's a few more sort of 10Ks and 1Ks, like the really common values that you use a lot. But still the chips were through hole. And but then eventually I went to the second largest size, which is 0805, and that's quite easy to handle. And the SOIC chips, which are also, they're the largest of the surface mount chips.
Okay.
I don't go any smaller than that, but there are other ones that do. You can still hand solder smaller ones, but it's not quite as easy.
Right. Well, one of the things I
Yeah.
noticed when I was playing around with some circuit design of my own is that I was starting to see myself being hampered because, especially with some certain kinds of logic chips and A to D converters and stuff, the things that had the capabilities that I wanted were actually only available in the SOIC format, and the through-hole stuff was a lot of times kind of a dumbed-down version. It was a little it was kind of disconcerting for me. And again, I was like, I was intimidated right away from it. It was a little rough. So I'm curious a little bit about your design process. I mean, you dropped a couple of names that I think are going to be pretty familiar to people in the module world. I mean, having a background sort of like embracing Ken Stone's work and Ian Fritz's work. I mean, these are people that have kind of this really long history. Well, and the Electronotes papers, right? These are all things that have really a long history in the modular world. Is there anybody, or is there is there anything that was maybe less common but equally equally important for you as your development as a designer?
Probably Serge and Ken. Definitely they're the main two. I mean, Serge not so much for his designs, because trying to get your head around Serge's designs was very difficult when you're new to this game. Yeah, he just, I guess he didn't come at it as an electronic engineer. I think he was a mathematician from memory. I can't remember now. But so his way of designing was really left field, and I get them now, but at the time I'd look at Serge's stuff and it was just the mystery. But it was his ethic and his view of synths and how people should be able to access them that I always liked. And but also his idea of how signal flow works, I think that was important. And similar with Ken Stone. But outside of those two, honestly, the biggest influences on my life would be probably John Waters.
Really?
Yeah, the films of John Waters.
That was an unexpected turn. I didn't see that one coming at all.
Yeah, just that whole, let's get weird and love it. And, as long as you're not hurting anyone else, do whatever really turns you on, that sort of thing.
That's awesome. That's a great thing to hear. I'm sure he would be pretty stunned to actually hear that himself. So that's really cool. So our time we're getting close to the end of our time, but before we go, I would like to ask you a little bit about how you had a very kind of peculiar way of getting into what you do. And I don't think that you would necessarily say that other people that wanted to follow your path into module making should work on a PhD in chaos theory. Right? But
definitely not.
Right. But I'm curious, what do you think now are the paths that would help people who wanted to want to go beyond building modules and maybe get into doing design? I mean, you're a very prolific designer. What do you think what do you think are some of the trails that can help people now who want to get into design themselves? Where would you suggest that they look?
Yeah, as much as I I do keep all my designs in analog, I sort of do acknowledge that the digital side of things is, where it's probably the big future of synths. Well, obviously it is. So learn how to code really well, but get your ideas from nature. Look at natural systems and how. And you mentioned about a spinning top. That's a beautiful idea. That sort of thing. Bouncing balls, how trees grow, evolution, if you believe in things like that. Mm-hmm. What dogs do when they go for a walk. Anything like that is a great place, a great source of ideas, and that's where I'm always looking, is natural systems. Yeah, so I can't. That's probably the best way to work, I think, and we probably don't need any more LFOs in the world.
Probably not. You're probably right about that.
Yeah.
One, kind of harkening back to how we first started our conversation, which was talking about the work that you had done with Guy on his cellF project. One of the things I noticed is that you actually put out a voice that was related to a voice board that was related to the synth that you developed for his thing.
Yeah.
How much of that was sort of like a combination of existing circuits, and how much stuff did you have to develop specifically for that project? I hate to go back to that because that's like a previous conversation, but I'll tell you what. I mean, there have been few projects I've talked about that simultaneously intrigued me and made me want to throw up a little bit. So I have this bizarre interest in what's going on there.
The novel part of the cellF project was the neural interface circuits, which if you ever look at pictures of it, that's the big black column in the center of it.
Okay.
With all the red twinkly lights. The two panels that I released from that, we call the voice panel and the action panel, mostly they were a result of what Darren Moore, who was the musical director of the project, what he wanted and what kind of sounds he wanted. So he had a lot of input on what modules went onto those panels. And of course, I stuck in the odd chaos circuit here and there,
Right.
'cause I just can't help myself.
That's what you do, right? Exactly.
Backup, I told him. I said, you might need it for backup if the cells die.
Nice. That's Plan B. Your Plan B modules, right?
Yeah. The interface stuff, that was actually the bulk of the work. That took quite a lot to develop how to communicate with a dish full of Guy's neurons.
Yeah, that's amazing stuff. Well, Andrew, I want to thank you so much for taking the time. This is a very fun talk and very revealing. And I mean, you actually have sort of like demystified the surface mount thing a little bit for me. So I have to tell you, that's when I looked at your projects, I was like, I could never do that because surface mount, right? But you've actually made it seem pretty approachable, and the fact that you're running workshops as often as you are and are seeing the success you are kind of tells a story as well.
Thanks so much for talking to me too. It's been a pleasure. Yeah.
All right, so with that then, I am going to let you have the rest of your day. Thank you so much. We'll have a good one.
Thank you, and thanks to everyone for listening too.
All right, bye now.
Okay, bye-bye.
Okay, many thanks to Andrew for the great chat. It was a lot of fun to get caught up, learn a little bit more about what he does and how he does it. It's a lot of fun. I also want to thank all of the people that have been supporting me, folks over at Synthtopia, folks at CDM, people like my friends and coworkers at Cycling 74, and the folks at Ableton, all the people that have really been kicking in help. I really appreciate it. I want to thank you, the listeners, also for your thumbs up, your back pats, your likes, your great reviews, everything. It all really helps to make this thing come together. And thank you so much for sharing this with the people that you know as well. That's the thing that really grows the crowd. Well, with that, I want to thank you, and we'll catch you next time around. Bye.